Hi, everybody. This is Mr. Gorsuch from Devani Ranch High School. Thanks for joining me. This video is going to be a demonstration of how you can use the DESMOS online calculator to help you with your homework basically all year. So this is going to be a very, very powerful tool to help you do some things. And I'm actually going to introduce section 1.4, but to do that, I want to introduce you to DESMOS first. So first of all, go to the website desmos.com/calculator. You don't want other ones like student.desmos or whatever. So make sure you do the desmos.com.calculator and go ahead and open up a window there. Now, what would be great is if you can have the video open and the Desmos open kind of at the same time. I don't know if you're able to do that, but it'd be great if you can kind of follow along with me here. Feel free to pause the video, while you go and try some of these things on your own, and then review, go back and see what I was doing to see if you can recreate there. So what I want to do is just start with a basic graph. So I'm going over here to the left, and I'm going to put y equals x. And that's the graph of y equals x. You guys remember the graph of y equals x. I actually want to start with exponential functions, though. So I want to turn this into y equals x squared. To do that, you have two choices. The first is hit the shift button and 6, which is caret, and then put a 2 up there. So there you see the graph of y equals x squared, a basic quadratic equation. In fact, we call that the parent function of quadratic equations. The other way to make the squared, if you'd like, is you can go down here to the lower left-hand corner and show the keypad. And you see one of the options here is a squared. So in this case, the a is already in there. It's x. So if you just push the a squared after you put in the x, it's going to put a 2 in there for me, which is really nice. So there's two ways to make the quadratic, the x squared things. If you want to put a minus 4x, you just write minus 4x. That's no big deal. And plus 3. So here's a different quadratic equation, right? That you could graph. And this can come in really, really handy. So if I gave you, let's say, this equation right here and asked you to graph it. Now, clearly on a test, we would want you to be able to do this conceptually. We want you to be able to do this without a calculator for some functions. But this one's kind of complicated. So what does that look like? Y equals 2x squared minus 16x plus 33. So I'm going to go over here and I'll go y equals 2x caret squared. And then what was it? Minus 16x plus 33. Minus 16x plus 33. And there is that quadratic function over here. And you notice I've got both of them graphed at the same time. Maybe I'm getting confused. So I can go up here to the left and I can erase the red one by just hitting the toggle there. All right, so what I really want to do is start investigating changes to what's called parent functions. So let's go back here to y equals x squared. And let's go down here and let's make a few changes to it, like y equals x, shift 6, caret squared, and then I'm going to put a minus 5 after that. Well, this is not a surprise. You guys spent a lot of time in algebra, but we're just reviewing with you that what that did is it moved the quadratic equation down 5 units. If instead it was plus 3, it would move the quadratic equation up 3. Now, realize, of course, we have a window here that's 10 by 10 approximately. It's actually going only up and down 8. So if I did something like plus 10, you'd probably say, wait a minute, this thing's broken. It's not showing me the graph. Well, it will not resize the window for you automatically. So you got to hit this plus or minus over here so you can resize the graph and get it on your screen. Okay, so it looks like when I have something after the x squared, like a minus 4, it moves it down 4. If I have a plus 2, it moves it up 2. Awesome, that's great. The other kind of changes you can make, if you remember, is you can move this quadratic left or right. And the way you do that is you put a number inside the function. The function is x squared. So you add those little parentheses there. And I'm going to put a minus 4. And remember that this is minus 4, and intuitively in our brain we would say that should move it left 4, but no, it moves it right 4. And the reason why is it's zeroing the function out, right? It's putting, if you put a 4 in for x, you get 0 out for y. So it's zeroing the function here to 4, 0, focal point or minimum value or something like that. Similarly, if I put in a +2 here, it's going to move the graph left 2. Okay, so we're comparing things. All right, so that's how quadratics work. And of course, you can combine those things. So here's an equation. I've moved this basic y equals x squared graph. Remember, here's y equals x squared. And I've changed it here in the blue to move it left 2 and down 4. So this blue graph is the exact same thing, translated that amount. Now, the same thing applies to different types of functions. Let's do absolute value function. Now, I don't know what the shortcut is for an absolute value function, so I'm going to go down here to the keypad, and I'm going to choose the absolute value icon there, and I'm going to put an X inside. So there's the absolute value of X, okay? And hopefully you remember that. The other thing that I want to show you now is that you can actually create a table of values. So let's put aside the y equals absolute value of x here for a second, and let's show you that you can create a table of values, which is pretty cool. If you highlight, if you actually go, you don't have to highlight any equation, it could be anywhere, I think. But if you just go up to the gear icon here, and let's say y equals x squared, you don't remember what x, y points go with y equals x squared, well, you can convert that to a table. Look at that. It put in the points right here, and it graphed it for me. So now I know that x equals -2, y equals 4, x equals -1, y equals 1, and it reminds me of what those points are. Okay, I'm going to deselect the quadratic up here to get it off my screen. I'm going to do the same trick with the absolute value. Again, to do this, you go to the gear icon up here, and you just choose Edit List, and you put table, convert to table. And there it goes. It converted it to a table for us. And it's not graphing it. Oh, because of the type of equation I have, I guess, or I'm not sure why it's not graphing it continuously, but we'll fix that in a second. So those are the points that go with the absolute value function. Okay, so let's go back here. So you can always create that table of values for a particular function by doing that. So I'm going to go back and create a y equals absolute value of x. This is a kind of cool trick, teacher trick. I'm going to deselect the x squared. You can also copy this guy. So you can go to the gear, you can go to copy and copy. And what I'm going to do is change the color here to the left. So I'm going to change this one to a red. I'm going to change this one to an orange. And I can actually change it to a dotted so I keep them clear, and I'm done. So now they're all graphed. And they're on top of each other right now because they're the same exact graph in different colors. So I'm going to make changes. Oh, let's go on this red one. Let's go +4. Oh, it moved the graph of, I'm going to deselect the orange for a second. It moved the graph of y equals absolute value of x, the parent function, up 4. Similarly, I could move it down, there we go, down 2. So the same thing that was going on with the quadratic functions, the parabolas going up, down, left, right, also applies to absolute value of x's, just a different function. If I put a +3 inside, I'm going to do a little teacher trick I think I learned here earlier today. I'm going to put a +3 in here, and I want you to stop the video for a second, and I want you to guess what movement that's going to make for the absolute value of x. How is it going to change? How is it going to be different than the purple graph? What change is going to happen? Okay, so hopefully you stopped the video. Now what I'll go do is I'll go in here and I'll take that little apostrophe out so Desmos knows what I'm talking about, and I guess I have to give it a color. So there's my graph, and hopefully you predicted right that it was going to move it left 3, just like it did for the quadratic equation. Remember, this quadratic equation, y equals x squared, and the new parabola that I did with +2 inside it, moved it left 2 and down 4. So the same thing is going on with this absolute value function. And then, of course, I can do a combination of things. I could go +6, and that would move it left 3, and up 6. If I wanted to move it right, of course, I would do a minus inside, move it right 3. If I wanted to move it down, I would move it down 2 or something like that. One other thing I think I want to talk to you about is you can, of course, investigate what happens when you put a minus sign in front of an equation. So I'm going to change and put a minus sign in front of this orange equation, and it's going to flip the same graph upside down, right? So I'm going to take it out, put it in, take it out, put it in, okay? So that's pretty cool to do that. I guess the other thing I want to show you on this is that you can't break this tool. So if you wanted to graph something completely different in a different form, like this, you might remember that this is called standard form instead of slope-intercept form. So 6x plus 5y equals 20. Let's go over here and graph 6x plus 5y equals 20. In other words, it doesn't have to be in that same form as slope-intercept, and it doesn't have to, it'll still graph the line. Close some of these others so you can see it. Okay, so this is the graph of 6x plus 5y equals 20. Now, if you solved this for y, if you rewrote this equation as y equals, and I think it would turn out to be something like minus 6 over 5x plus 4. But in fact, why don't I just do that? Y equals negative 6 divided by 5. I'm doing this math in my head, but if you solve this equation for y, you would get that. And I'm proving that those are equivalent forms of the same equation. But my point is you can graph in any form that you want. It doesn't have to be y equals. In fact, it will also take that dreaded f of x equals. Okay, no problem using f of x instead of y, and there's advantages to that as you do other higher level things. So you can type f of x in instead of for y if you want to do that. I hope you found this helpful. I hope you will explore it. I hope you will use it as a help tool for you when you're going to do graphing in this class. You can really learn a lot by making sure that you're graphing things correctly. Desmos is a great tool to do that. So hope this was helpful to you, and we'll see you on a next video, and we'll cover the actual content in 1.4 a little more.